See, I haven't used Zoom in a minute, so let me just get this together. Okay, so we're going to go over some of the problems on your EOC packet number 1 answers. So let's go ahead, go to number 2. This is your number 2. All right, so this one is weird. It's not hard, it's just a little oddly worded. So translation A maps AY to A plus R, Y plus S. So go to translation notes. I believe you're there, your notes number 2, and look at what it means to translate. So to translate means to slide. And so when you have X plus anything, X plus means you're going to go to the right. X minus means you're going to go left because that's your X axis. Your X axis runs right and left. Then you have your Y axis runs up and down. So Y plus means you're going to go up and Y minus means you're going to go down. So here, when it says X plus R, that means they're going to go right first. Y plus S means they're going to go up. Then it says translation B maps XY to X minus A, which means you're going to go left, and Y plus B, which means you're going to go up again. So it says translate a point using translation B, then translation A. Write a rule for the final image of the point. So what it's saying is that you want to do both of these at one time. So you're going to do B, and then you're going to do A. Okay, so you start with X and you're going to go minus A. So you're going to go to the left and then you're going to go back right plus R. And you got those from above. Then you're going to do the same thing with Y. You're going to go up first and then you're going to go up some more. And so that is your final answer. It's very abstract. There's no numbers and it's not super hard, but now that you see the answer, it should make sense. Okay, so now let's go to number 3. Number 3, I think most of you did it yesterday. If you didn't, I just want to make sure that we get the answer up here. Once again, you're talking about translations for number 3. And it says that you're starting with your point S at -4, 5. And then you're translated to S prime, which is 3, 1. Okay, so it's asking you to describe the translation. So that means what are you doing from this X value to get to this one? What are you doing from this Y value to get to that one? And so you got to figure out, how do I get from -4 to +3? You're going to add 7. And how do I get from +5 to -1? You're going to subtract 4. So your answer should be C. You could graph these if you wanted to and count how you move. And the same thing should work with T. So if you're looking at T, to get from -2 to +5, you would add 7. To get from +1 to -3, you would need to subtract 4. So your answer for number 3 is C. All right, let's look at number 4. You really need to graph number 4, and I don't have graph paper right now, so I'm going to explain it without using graph paper, but it would make way more sense for you if you would graph it, at least for the very last part. Okay, so you have a square. Those are its vertices. Which statements are true of the image after applying the given composition of the transformation? So step 1 says that you need to apply this transformation. Okay, you need to go to your reflections and rotation notes and see which one this applies to. So if you go to your reflections notes, I think those are notes number 2 and 3, look at your rules. See if anything is -YX. And if you look at it, you should see that nothing applies. So then go to your rotations. Okay, your rotations do apply. There is this rule here. It's the 90 degrees counterclockwise rule, or it's the 270 degree clockwise rule. Okay, so the first thing you're going to do is rotate. Then if you look here, this is 3 times X and 3 times Y. The only time that we get things bigger is through a dilation. So then you're going to dilate times 3. So you're spinning it and then you're making it bigger. And so it's asking you which of these are true. Okay, so if we go look at H, so H is 0, 2. if we apply this rule, negative yx, it means that you need to flip your order and you need to make the first number opposite. So 0, 2 is going to become 2, 0, and you make that first value opposite. Then to get to h double prime, we need to move it again. And so if you move it again, that means we need to multiply each of these by 3 to make it bigger. So then you get negative 6 and 0. So that is obviously not which h double prime is, so this one's out. Okay, the next part. It's asking you if hij, this is the first figure, and this is the second figure, and it's asking you if they are congruent. We'll go back to step 1. If you're rotating, your figures always stay congruent, so this is true. Okay, I'm going to delete some stuff up here so you can see better. So this one's out, this one's true. Then we go to the next box. It says hij prime is congruent to all the double primes. So you're going from the rotated figure to the dilated figure. This little symbol right here means similar, and similar means same shape, different size. So anytime that you see the similarity sign, you should immediately be thinking dilation. Dilation makes figures similar. They are the same shape, but they're different size. So because we're dilating here, they are similar. Okay, so then you should be able to do the math for J just like we did for H. So if J is 0, negative 2, and then you flip them and make the first one opposite, that would be 2, 0. And then if you multiply them both by 3, you would get 6, 0, J, J prime, J double prime, which is correct. So far we have, and if you need to pause this video at any time, pause it. So we have the first one's out, the middle 3 are in, and we got to check the last one. A lot of people just didn't know what this line is. They were assuming it was the x or y axis. Y equals x is a line, a graphed line. The y-intercept is 0. The slope is 1 over 1. So start at 0, up 1 over 1, up 1 over 1, up 1 over 1. So this is your line, y equals x. Okay, then if you graph it, that's what I'm saying, you really should graph it for this so you can accurately see this, but I'll try to do the best I can. So this is your square. So it's asking you for the last one, is y equal x a line of symmetry for hij, and hij, all double primes? So it is for hij. Okay, line of symmetry means cut it in half. Okay, so if you were like, it matches up. Okay, so then if you make it bigger, it's still going to be. So if I make it 3 times as big, just assume it's going to be somewhere up here, over here, over here, over here, over here. It's still cutting it in half because it grows proportionally. So this is also an answer choice. So last 4. Number 5, let's go to the next page. Number 5 is very similar to number 4. They're talking about lines of symmetry, or the concept kind of. All right, so your big words here that you need to make sure you understand is the which of the following transformations will take polygon A onto itself, okay? And so we did problems earlier in the year that was like mapping onto itself. That means that anytime if you spin this shape, if you flip it, if you translate, whatever you do, it needs to end up, these points need to end up matching up, and this shape needs to be turned exactly the same way on top of itself. None of these points are labeled, so it doesn't matter which point, like it doesn't matter where it ends, but it needs to in the end be the very same shape. So it says a reflection over y equals 1. If you don't know where y equals 1 is, you need to go to your notes number 1. They're yellow. They're the very first set of notes. They're vertical and horizontal lines. So y equals 1 is actually a horizontal line. So we're talking about this line right here. Okay, so it's asking you, if I flip this point over to here and this point over to here, these 2 points obviously stay. Will it reflect onto itself? And it does, because it splits it in half. If it splits it in half, then it reflects onto itself. All right, so that's the first one. Now the second one, a rotation of 360 degrees about -3,1. Well, if you look at -3,1, -3,1's right in the center. So if I take a rotation and rotate a full circle, then it's always going to be in the same place. So this works. If this point was different, it may not, but because it's on the center, it's like the origin. You're just spinning it around itself. Okay, so then you have a reflection over the line x equals -3. X equals -3 is a vertical line. And so does it split it in half? Does this point reflect to this one? Yes. Does this point reflect to that one? Yes. And remember, reflections are all about the distance from the line you're reflecting over. So if it's 2 to the left, it'll flip and be 2 to the right. Same thing here. This point reflects to that point. So this is also an answer choice. Excuse me. All right, last two. A rotation of 90 degrees. So remember, if you think about over here, if you have a rectangle and you turn it 90 degrees, 90 degrees is going to end up standing it up like this. So because this figure is longer than it is tall, if you rotate this 90 degrees, it doesn't matter which way you're rotating it, it's going to end up standing up taller. Something like this, obviously a terrible drawing, but it's going to end up standing up taller than, and it's not going to match. So this one can't work. And if you want to totally rotate it, then you have rotation rules, not about the origin. You can look at those notes, like if you wanted to do it on this paper. And then it talks about a rotation of 180 degrees. 180 degrees is going to turn the figure and turn it upside down. Okay, because it's half of a circle and you're rotating it about -3,1, about the center. So what that's going to do, and you can kind of think about it like this, 180 degrees is a straight line. So that means it's going to take this point and match it up to that point, and they are going to be, it's going to totally turn it upside down. So those are your answer choices. Y'all, hold on one second. Hello. Hey. Yeah. Mm-hmm. Yes. Oh, okay. Oh, okay. My husband's getting a ticket because he won Glenn Howell. So technically they're paying for him a ticket. So yeah, let me see and I will let you know. Okay, thanks. Bye. Okay, sorry guys. All right, so now let's go to, let's look at number 6. Number 6 is tricky. A lot of people got 6 wrong. I got 6 wrong to begin with, because it's the last answer choice is super tricky. All right, so this is once again, just like number 5, talking about lines of reflection, and you're talking about mapping it onto itself. So it needs to be in the very same exact spots. All right, so if we reflect this over the x-axis, that means B is going to be down here. That's automatically off, okay? It doesn't match up, so this one's not going to work. Okay, same thing with the y-axis. The y-axis does not split this in half, and so when you take B, if it's here, it's going to flip over to the -3. Once again, y-axis doesn't work. Okay, then 90 degrees about the origin. Okay, so you can pick a point. So let's look at B. B's ordered pair is 3, 3. If you look at the rules for rotating 90 degrees, there's 2 options, and we can rotate 90 counterclockwise if you want to. That rule is you flip them and you make the first number opposite. So we're going to flip the 3, 3. which looks the same, and then you're going to make the first one opposite. So B would rotate to -3, +3. This would be, and you can see it here, I think we talked about this, you can see the 90-degree rotation. So again, that one doesn't work. Okay, 180-degree rotation. 180-degree rotation, the rule is that both numbers become opposite. So for 180 degrees, you make it's the opposite of both your x and your y. So that means 3, 3 would turn into -3, -3. So B rotates to D. A would rotate to C and everything. So everything would match up. B doesn't go to B, but it is still on itself. And so they're counting that. All right. So usually when it says select all that apply, there's more than one answer. Well, sometimes they make these wrong. So for this one, there's actually only one right choice. A lot of people pick this one, and I totally see why. So you're talking about a reflection over the line from A to C. Okay, so let's start with D. And the way that I taught you how to reflect over lines is you go to the line. Okay, so for instance here, 1, 2, 3, 4, 5 to the right is going to then be 5 up. 1, 2, 3, 4, 5. Just kidding, something's wrong. 1, 2, 3, 4, 5. Something's weird about this graph. This point, 1, 2, 3, 1, 2, 3. Something's odd about this graph. I think that they're not squares. I don't know. But if you reflect, B does reflect to D. Like they copy to each other. The problem is the lines don't. So let's look at this point right here. So let's look, it's about 2.5. Let's just do for some estimating purposes. So it is 1, 2.5 lengths from the line. So if you would go, if you're flipping over this line, then you would flip up 1, 2.5. That means that that point should be there, which means that this line is not going to reflect to that line. So that means that this one is also out. So there is only one answer choice for number 6. Okay. A lot of people also got number 7 wrong. So we're going to go over number 7. All right. So it's asking you again, which ones are going to carry it back onto itself. Okay. So because this is very much like a rectangle, we're talking about like it's kind of taller than it is wider. If you rotate this 90 degrees, it's not going to match onto itself. So anywhere that you see 90, you can take out. So it can't be A. 90 degrees is not going to rotate about itself, and neither is this 90. Okay, so then we've got to look at B and D, and let's look at the differences between there. So they both have rotated about 180 for and 360 about point E. Okay. So that means that A is going to go to C, B is going to go to D. So the 180s work. So this is good and this is good. The 360s, obviously, if you rotate about 360, it's going to be in the same spot. So 360 and 360 work. So the question here is this part right here, reflected over AC. So if this is your line of reflection, that means that we're flipping this. Like if you had it on paper, you're flipping it over. And so when you flip, it's flipping at a 90-degree angle. Okay. So that means that D is going to end up flipping somewhere over here. And D obviously doesn't match up with B. So that means that B is out. And D is your correct answer. Okay. A lot of people have had questions about 8. I don't love how 8 is written, so we're just going to skip over 8. 9, I have not had a chance to work on yet. Most of you can probably get that if you look, make sure you go back to your notes number 1, talking about vertical and horizontal lines. But 10 is really easy to go over. So let's all go to 10. There's really no work involved for number 10. You just have to understand your transformations. Okay, so number 10. Which of the following transformations will produce congruent figures? So this is important. We have translations, we have reflections, we have rotations, and we have dilations. Okay, translations are a slide. This keeps the figures congruent. If you slide up, down, left, or right, you're not getting bigger or smaller. Reflections, if you flip left, right, up, and down, figures stay exactly the same. If you spin or rotate figures, they stay exactly the same. Dilations are the only ones that do not stay congruent. They get bigger or smaller. They are similar. So when you're talking about congruent figures, dilations use multiplication. So you need to go through here and find anything with multiplication, and you need to exit out. So the half, okay, that would mean that this one is getting smaller. So this one's out. Okay, same thing here. You're making it twice as big and then you're shifting it. So this one's out. Same thing here. This is 3 times as big. This one's out. Okay, so then let's look at what we have left. The first choice, you're moving it 4 right, 2 down. This works. The next choice is a little bit weird. I think there's a reflection in there, and then you're moving it, but still you're not multiplying anything by a value greater than or less than 1, so that is still an option. And then the next one, this is 180-degree rotation, so that one's in. Okay, let's go to number 11. It says find the value of x and y in the rotation of ABC 120 degrees clockwise about point P. Triangles are not drawn to scale. Okay, so the rotation part here really doesn't matter. I mean, I guess it kind of does. You're rotating it clockwise like a clock. However, they give you A prime, B prime, and C prime. So you have the sides that are corresponding to each other. And after a rotation, you know the side lengths are the same. So that means that AC must be equal to AC, and CB must be equal to CB. Okay, so then that allows you to solve. So you have obviously you have to start with CB because you have 2 variables for the other side. So you have 5y equals 15. So y equals 3. And then you take that y and plug it into that. So then you have AC is congruent to A prime C prime. So you have 5x is equal to 4y plus 8. You just found out that y was 3. So 5x equals 4 times 3 plus 8. So 4 times 3 is 12. 12 plus 8 is 20. So you have 5x equals 20 divided by 5. X is 4. So you just have to understand that rotations keep them congruent, and then you can set your sides equal. Okay, the last one that we are going to go over today is number 12. Okay, so what transformation is going to take ABC to A prime, B prime, C prime? So this is super important. Okay, looking at the triangle, this is A prime, B prime, C prime. I mean, my bad, ABC. And then this other one is A prime, B prime, C prime. Okay, so when you're rotating, your points aren't going to match. Like I think some of you are going to like when you move them, if you were to turn them this way, then B, or my bad, let's maybe move it this way. If you were going to turn A, B, C this way, then B would go to B prime, but that means C is going to go to A prime and A is going to go to C prime. So that's a problem. Okay, so you shouldn't be using any rotations. So this rotation isn't going to work. Then a translation. I mean, obviously, if you take this figure right here and you translate it 2 down and 2 right, it's still going to be turned this way. So translations doesn't work. So we need to look at the 2 reflections. Okay, so and your 2 choices are y equals x and y equals negative x. So when you have your picture, y equals x, it starts at 0, up 1 over 1. This is y equals x. And then your y equals negative x is the opposite way because your slope is negative, down 1 over 1. This is your y equals negative x. Well, if you graph y equals negative x, does it look at any point that that was the reflection? No, because you would have to have things going, reflecting this way. So y equals negative x can't work. So now let's see why the answer is y equals x. Here's your graph of y equals x. And then look, B is 1 over, it flips 1 over, so B checks out. C is close to the line, so it's easy. C, 1 over, 1 over, C checks out. A, you can do this a few ways. When it gets further away, it's kind of hard to see, so I kind of like to go directly down and over. So 1, 2, 3, 4, 5 down is going to be 1, 2, 3, 4, 5 over. So everything matches when, and if you look at it, it kind of splits everything in half. So D is your correct answer. Okay, hopefully this helps some of you, and I will upload another video for Friday if you're on the band trip for the rest of the questions. This should be good enough for tomorrow, and for the other ones, if you're in class on Thursday, just work through the rest of them. A lot of the ones at the end have to do with your congruent triangles. So go and look at your pink notes. There's a bunch of answers in there, and we will continue to work on this on Friday. You guys have a great day. Let's see if I can stop this. Stop and end.